with the reward. The aim for the agent to reach the flat on the top of the right hill as rapidly as possible. As a result to the agent is penalized with the reward of the minor grant for X time step. It does not achieve the goal and is not uh, doesn't get the penalty with the reward equal zero. But it does the great the goal. This is the flat on a hill. For episode termination, the episode terminate if either of the following happen. The position of the card is greater than or equal to 0.5. The goal possible on top of the right hill. The length of the episode is 200. And for the solution here, we have I have the Q learning on the top. And the TD learning. I use let's say the TD0. Q learning for this problem, and on top, and for the solution, this is the fundamental difference between two methods is Q-learning defines the same space in the vehicle and learn the best value for each state, allowing the model to learn to the extremely complicated mapping. It learn the mode mapping between the state space and the value function use the TD learn the above. Um, we can see here the with the Q-learning is more complex in on the wrap. Here we can see the zero. The zero is when the card it reached the goal, and it's need so many time to go and to reach the goal. But on the TD learning is more efficient and not too much time to get the goal. The goal. Yeah. And with the conclusion, we can have some different in three problem when we use the green Pullman on tourism and the Q learning on tourism and the TD the temporal different on tourism. For the Q learning, in the taxi problem, the Q learning method effective for the taxi problem because it allows the agent to learn from the failure and make the next best move. As a result, the incentives are lower at the start of the tourism and grow as the number of episodes increase. Uh, because the tourism is efficient and the agent perform the optimal action to complete its proposal. Uh, proposal. With the couple problem, the couple issues we require a large number of the time step for each episode with the co-learning, so cannot provide is the co-learning cannot provide because the random method is employed for the couple problems is the more better, more efficient than the co-learning. With the mountain car problem, it's learned to randomly perform action until the recognize the action will give the higher score. It gets the small boost. Its high score if the reaches the flat, and it gets more and more points if it gets you flat faster. Therefore, using the TD learning to train the mountain car to get the flat as fast as possible to possible and effective. But when I test the algorithm, also have some some case problem with the algorithm that the TD learning sometimes is slower, but not too much case in there, and maybe that's some problem, and it took longer time to run to solve the mountain car problem, but that's just some accepted something not right, and it gives some bad solution, yeah. And this is my presentation the for the final project about the reinforcement learning Sit215. Thank you for listening.